Assalamu alaikum. In a previous lecture, we have studied chapter 1 and introduction of chemistry. In chapter 2, we will study structure of atoms and we will study some pre-readings and then I will explain you theories and experiments related to the atomic structure. Mainly we will focus on the Rutherford and Bohr atomic theory. So we can start our lecture by pre-reading. The structure of atom tells how the subatomic particles are arranged. Atoms are so small that they can only be visualized with the scanning tunneling microscope. See figure 2.1. Where is figure 2.1? This is figure 2.1. That shows an image of gold atoms on the surface. In grade 7 you have studied. You have learned about the structure of atom and subatomic particles, electrons, protons, and neutrons. In this chapter, you will learn about the arrangement of these particles in an atom. Atomic structure was formulated from a series of experiments during the later part of 19th century and the beginning of the 20th century. We will discuss the contributions of British physicist Rutherford and Danish physicist Neil Bohr for determining the structure of an atom. Bohr's structure of an atom nicely explains the arrangement of elements in the periodic table and periodicity of properties. How? To understand this, you should know the structure of atoms. So we will study now structure of atoms. First we will study Rutherford atomic model. In 1911, Rutherford performed a series of experiments in order to know the arrangement of electrons and protons in atoms. What is Rutherford experiment? Rutherford bombarded a very thin gold foil about 0.00004 cm thickness with A particles, mean alpha particles. He used alpha particles obtained from the disintegration of polonium. Alpha particles are helium nuclei that are doubly positively charged. Helium doubly positively charged. Most of these particles passed straight through the foil. Only few particles were slightly deflected, but 1 in 1 million was deflected through an angle greater than 90 degrees from their straight paths. Rutherford performed a series of experiments using thin foils of other elements. He observed similar results from these experiments. Rutherford drew the following conclusions. Number 1. Since majority of alpha particles passed straight through the foil, most of the space occupied by an atom must be empty. Second, the deflection of a few alpha particles through angle greater than 90 degrees shows that these particles are deflected by electrostatic repulsion between the positively charged alpha particles and the positively charged part of atom. Third, massive alpha particles are not deflected by electrons. On the basis of conclusions drawn from these experiments, Rutherford proposed a new model for an atom. He proposed a planetary model similar to solar system for an atom. An atom is a neutral particle. The mass of an atom is concentrated in a very small dense positively charged region. He named this region as nucleus. The electrons are revolving the around the nucleus in circles. These circles are called orbits. The centripetal force due to the revolution of electrons balances the electrostatic force of attraction between the nucleus and the electrons. So he proposed this experiment and made some conclusions, but it has some defects. Rutherford model of an atom resembles our solar system. It has following defects. Classical physics suggests that electron being charged particle will emit energy continuously while revolving around the nucleus. Thus, the orbit of the revolving electron becomes smaller and smaller until it would fall into the nucleus. This would collapse the atomic structure. If revolving electron emits energy continuously, it should form a continuous spectrum for an atom, but a line spectrum is obtained. Bohr formulated a new explanation and a new theory to remove defects from Rutherford models. So, Rutherford model has some defects, and Bohr proposed a new theory to remove these defects. So, in 1913, Neil Bohr proposed a model for an atom that was consistent with Rutherford's model, but it also explains the observed line spectrum of the hydrogen atom. Main postulates of Bohr's atomic theory are as follows. Number one, the electron is an atom in an atom revolves around the nucleus in one of the circular orbits. Each orbit has a fixed energy, so each orbit is called energy level. Electron revolves in these circles and each circle is called orbit or energy level and they have fixed energy. Number 2. The energy of the electron is an orbit is proportional to its distance from the nucleus. The farther the electron is from nucleus, the more energy it has. If electron lies in the outermost circle, it has more energy than the electron lies in the first circle. Third one, the electron revolves only in those orbits for which the angular momentum of the electron is an integral multiple of I divided by 2 pi, where h is Planck's constant. Its value is 6.626 multiplied by 10 power minus 34 joules. Light is absorbed when electron jumps to a higher orbit and emitted when an electron falls into a lower energy orbit. Electron present in a particular orbit does not radiate energy. The energy of the light emitted is exactly equal to the difference between the energies of the orbits. Where so this is the calculation of energy. If electron jumps from higher to lower, it releases energy. No, let me read again. Light is absorbed when an electron jumps to higher energy. When electron jumps from first orbit to the second, energy is absorbed. When it jumps from outermost orbit to the lowermost, energy is released. So these are the two models. Now we will study science, technology and science, society, technology and science paragraph. Rutherford Rutherford was the first scientist who proposed the first atomic model of an atom. He suggested that all the positive charge and the most of the mass of the atom is concentrated in the nucleus. The remaining volume of the atom is occupied by electrons that revolve around the nucleus in circles called orbits. These suggestions remained unchallenged, but his model could not explain the stability of an atom and line spectrum for an atom. Bohr leaped over difficulty by using quantum theory of radiation that was proposed by Max Planck. Bohr proposed that an electron moves around the nucleus in a well-defined circular paths called orbits. An orbit has fixed energy. Electron present in an orbit does not emit energy. Bohr atomic theory explains nicely the stability of an atom and also explains why an atom gives the line spectrum. Development of Bohr's atomic model explain how interpretations of experimental results of other scientists help chemists to formulate new explanations and new theories. So this is for today. Now we have studied structure of atom and 2 atomic model by Rutherford and Bohr. And write down in comment which lecture you want in next video. This is for now. Allah Hafiz.